this video, we're going to look at the third and final example from the practice balancing redox equations practice sheet. So in this example, we have ClO2 plus SbO2 minus yields ClO2 minus plus SbOH6 minus. The first thing you have to do whenever you're balancing redox is you always have to assign oxidation numbers first. So even before any of these steps to balancing redox, at the very, very top, you always need to assign oxidation numbers, because if your oxidation numbers don't change, it's not redox, and so you can balance it like normal. So let's go through and assign oxidation numbers to all of the individual elements. So each oxygen here is -2. Remember that oxygen always carries a -2 charge unless it's in its elemental form or it's with fluorine. If each oxygen is -2, that gives this total oxygen, the O2, -4, which means that Cl must be +4. Remember that unless there's a charge, unless it's an ion, it should always add up to equal 0. Again, oxygen is -2, each one. The numbers that I'm going to be putting on the bottom are each individual element. So each oxygen is -2, which means all oxygens have a combined oxidation of -4. Now antimony, we have to figure out what antimony must be to make everything equal -1. And so antimony then must be +3. Now we look at ClO2 minus. So again, each oxygen is always -2, total oxidation of -4, which means Cl must be +3 because we have to have it equal -1. And then finally we have SbOH6 minus. Now this could look a little tricky, but what you want to do is use polyatomic ions that you know. So for example, every OH, that's hydroxide, every OH is -1. So there are 6 of them, which means total this is -6. So we have to think what antimony would have to be to make everything equal -1. So antimony must be +5. Now based on hydroxide being -1, then we can figure out the oxidation numbers of oxygen and hydrogen. So oxygen is always -2. Since hydrogen is bonded directly to oxygen, it's going to carry a +1 charge, which makes sense. That's why every hydroxide is -1. So now we have all of our oxidation numbers. So what we need to do is we need to figure out the half reaction for oxidation and reduction. So we have chlorine going from +4 to +3. So its oxidation number is going down. It's being reduced. So the reduction half reaction is ClO2 yields ClO2 minus. The oxidation half reaction then must be the other part. So oxidation will be SbO2 minus yields SbOH6 minus. So we have our reduction half reaction and our oxidation half reaction. So once we have the half reactions, then we can go through each of these individual steps for each half reaction. So to start, we want to balance everything except for hydrogen and oxygen. So 1 chlorine, 1 chlorine, that's fine. 1 antimony, 1 antimony, that's fine. Then we want to balance oxygen. So we have to go in this order. So after we balance everything except for hydrogen and oxygen, then we just balance oxygen. So I have 2 oxygens in the reduction half reaction, 2 oxygens, so that's fine. When I look at the oxidation half reaction, I have 2 oxygens and 6 oxygens. So to balance the O's, you have to use water. So if I have 2 and 6, that means I need 4 waters on this side. And then after your oxygens are balanced, then we balance hydrogens. But to balance hydrogens, we have to use H+. So I don't have any hydrogens in the reduction half reaction. So if I look at the oxidation half reaction, I have 8 on the reactant side and 6 on the product side. So I need to get 8 hydrogens, and so what I do is I have to add 2 more H+ to the product side. So now I have 8 hydrogens, 6, 7, 8 hydrogens, 6 oxygens, 4, 5, 6 oxygens. Once all of your atoms are balanced, then we balance the charge using electrons. So for the reduction half reaction, I have a charge of 0 on the reactant side and -1 on the product side. Since you're balancing using electrons, remember electrons are negative. So this is -1, this is 0. I'm going to add 1 electron to the reactant side. So now this side is -1, this side is -1. They don't have to be 0, they just have to be equal. So the reduction half reaction is balanced. So now if I look at the oxidation half reaction, water is neutral, so I have -1 on the reactant side, -1 plus 2 on the product side. So total I have -1 on the reactants, +1 on the products, which means I need to get them equal. You make them equal with electrons. Electrons are negative. So I'm going to add 2 electrons to the products. Notice that I added the electrons to the opposite sides in each half reaction. If you are adding them to the same side, something is wrong. They always should be added to the opposite sides because reduction is gaining electrons, so it's a reactant. Oxidation is losing electrons, and so it should be a product. Now, once we have the charge balanced, then we have to make the electrons equal. So I have 1 electron in the reduction half reaction and 2 in the oxidation. So what I can do is I can multiply this top reaction by 2. Once I have them equal, then I can add the reactions and I can cancel anything out. So I can cancel anything that is the exact same on both sides. 2 electrons on the left, 2 electrons on the right. So I'm just going to write everything out. So 2 ClO2 plus 4 H2O plus SbO2 minus yields 2 ClO2 minus plus SbOH6 minus plus 2H plus. So here is my balanced redox reaction. Now, we are assuming acidic solution. That's what the instructions tell us to do. I want to look at what would happen if this were basic, because in this entire practice sheet, there were no basic solutions. So I want to look at what happens if it says that this was basic. So you would have gone through all of these steps the exact same way. The difference, if it's basic, is once you get to this part at the very end, you have to neutralize any H plus using OH minus. Now, if you add OH minus to one side, you also have to add it to the other side. So if we look at this, we see H plus. Well, if it's basic, you can't have H plus because H plus tells you that it's acidic, which means I have 2 H pluses. I need to neutralize that using 2 OH minus. Now, if I added 2 OH minus to neutralize the H plus, if I added 2 OH minus to the products, then I also need to add 2 OH minus to the reactant. Now we have to think about what this ends up equaling. When you add H plus and OH minus together, what do you get? You get H2O. So if I have 2 H plus and 2 OH minus, that gives me 2 H2O. So this becomes 2 H2O. Now make sure that you cancel anything else out. So if I have 2 waters now on the products and 4 in the reactants, I can cancel out these 2 and make this a 2. And then I can rewrite. So if this were a basic solution, I would have 2 OH minus plus 2 ClO2 plus 2 H2O plus SbO2 minus yields 2 ClO2 minus plus SbOH6 minus. So this is if it were a basic solution. Notice how you see the OH minus. So that's the difference if you have a basic solution versus an acidic solution.